Alright, so in this video we're going to prove that square root of 2 is irrational, and we may use the fact that for an integer n, if n squared is even, then n is even. And it's often difficult to prove something is irrational using a direct proof, so we're going to use a proof by contradiction here. So we start by saying suppose, by way of contradiction, square root of 2 is rational. Then there exist m n integers mn such that square root of 2 equals m over n with n not equal to 0. Now here's the important part for this proof. We need to assume that m over n is in lowest terms, meaning that the GCD of m and n is equal to 1. So then we can write square root of 2 is equal to m over n and square both sides to get 2 is equal to m squared over n squared, and then 2n squared equals m squared. So this gives that 2 divides m squared. Then, by definition, m squared is even. Then, from the fact given, we know m is even. So, by definition, there exists k, an integer k, such that m is equal to 2k. So then we have 2n squared is then equal to 2k squared, which gives us 2n squared is equal to 4k squared. So then n squared is equal to 2k squared. And then, since k is an integer, we know k squared is an integer. And so, by definition, 2 divides n squared. This means that n squared is even. And then from the fact given, since n squared is even, we know n is even. So n is even from the fact. Then since n is even, we know 2 divides n. So we now have that 2 divides m and 2 divides n, which is a contradiction because we required that m over n be in lowest terms. So this contradicts that m over n is in lowest terms. So therefore, square root of 2 must be irrational.